In a previous episode, we spoke about measurement system analysis, or MSAs, and specifically about what we know as a Gauge R&R, repeatability and reproducibility study. We talked about whether you should run two or three operators over two or three repetitions. And I mentioned that we should use somewhere between 6 to 10 parts, but I left that for another episode. Well, now is the time to seize the day. Little reference for all the Broadway fans out there. Now, there are a lot of misconceptions and thus questions about parts. Let's clear some of those up. So here's one. I've heard that you should get parts that are in the middle of my distribution, so most of them will be the same. And the answer is no. You want just the opposite. The further apart your product is, the more you can determine whether your gauge has the ability to discriminate between the different parts. Goal, and its goal, is to pick parts that could happen in normal production. Even though the frequency of seeing parts out of spec is small, you still want to know, can my gauge actually pick that up and discriminate between something in spec and something out of spec? Super important. Here's another question. Is it an issue if two or more parts are identical? And the answer is, well, it'd be nice if they were different. Ideally, you want them equally spaced from your minimum to your maximum. But sometimes you don't get that luxury. Getting them spread out is good enough. Here's another question. We must have 10 parts. The answer, well, 10's a really good number. As long as you have a good range represented, 10 is more than sufficient. But you can actually go down to 6, and I've actually run a gauge study with 5 simply because we had no other parts. But there is a loss of power in your study that comes with that compromise. Here's another question. Why do I have to randomize the parts between repetitions? The answer, always, without fail, randomize, period. It is so critical. Now, while we're pondering this answer, please like and subscribe down below. So let's say that we had an automated gauge. This gauge has no memory of what we got the first time. Why would we have to randomize? If there is something in the environment that is drifting over time, that drift is getting embedded into our random error, which is repeatability. So we're going to potentially lose the ability to detect a signal. But oftentimes we're using human beings to measure products. Randomization is super important so that they don't remember what values they got the first time. If you don't randomize, they're going to remember some of the values. Now, when they can remember some of the values, they will make sure they get the exact same value the second and third time. Even if they got it wrong the first time and the second time they measured, they came up with a different number, they can't admit that they made a mistake. So they will force that measurement back to whatever they got the first time. Human beings have the memory registers to remember 5 or 6 things. When you have 10 parts, human beings simply cannot remember 10 numbers. You try to memorize 10 numbers, you can't do it. Especially when you randomize the parts. It's so much for our brain to process, you will get a more honest representation of measurement error. So the bottom line, for a standard Gauge R&R study, run 6 to 10 parts. Closer to 10 is better. Spread out in value as much as possible and randomize them between repetitions. Hope that helps.